Section 2.4 is titled Dividing Rational Numbers. So the standards we'll be working with today are computing rational numbers, using order of operations, and also solving any real-world problems that might involve rational numbers with one or two operations. And the two operations we'll be focusing the most on today are multiplication and division. So the first definition is reciprocals, and reciprocals are two numbers whose product is 1. Remember that product means multiplication, so they're two numbers that when you multiply them together, you get 1. And if I show you a number and ask you to find the reciprocal of it, you're essentially going to take that number as a fraction and flip it. So you make the numerator the denominator, and you make the denominator the numerator. So let's look at some examples. Find the reciprocal of each number. So again, the reciprocal is found by flipping the fraction, flipping the numerator to the denominator and the denominator to the numerator. And we want to be careful here. We don't want to use an equal sign when we're writing reciprocals. We're just going to write it next to it, 16 over 7. If you were to multiply these two fractions, you would get 1. But you can see why we don't want to use an equal sign, because these two fractions are not equal. When you have a mixed number, like in example 2, negative 6 1/3, we want to write it as an improper fraction first, so we're going to candy cane it. 6 times 3 is 18, 18 plus 1 is 19, so we get 19 thirds, and it is negative. So now when we take the reciprocal, we're going to flip that fraction, we're going to get 3 over 19, and the reciprocal is going to stay negative. Remember that when you're candy caning a mixed number that's negative, you ignore that negative sign first, make the number a mixed number, and then put the negative sign back on. Try 3 and 4 on your own, so please pause the video. You're writing 3 and 4, you're writing the reciprocals. So for number 3, we would get negative 9 over 7. And for number 4, 2 times 12 is 24, 26 over 12. That actually can be reduced. We should probably reduce that first. This is 2 12ths, which is actually 1/6. Let's do it that way instead. Let's reduce that 2 12ths down to 1/6. Now let's candy cane it. 12, we get 13 over 6. And now when we take the reciprocal, we get 6 over 13. So when you're finding reciprocals and you have a mixed number, you need to write it as an improper fraction first, and then take the reciprocal. So today's lesson is just about dividing fractions. To divide by a fraction, you're going to multiply by its reciprocal. And you're going to hear me say this often, so make sure you almost have this line memorized. I will ask, how do you divide by a fraction? Your response would be multiply by its reciprocal. So you'll notice here in the example we have a over b divided by c over d. So we're going to keep the a and the b the same. We're going to change the division to multiplication. There's the multiplication. And then you were going to take the reciprocal of the second fraction. So then there's the reciprocal. Instead of c over d, we now have d over c. So 4/9 divided by 3/5 becomes 4/9 times 5/3. Again, taking the reciprocal of 3/5, then you would multiply across the top, multiply across the bottom, and then check at the end if the fraction can be reduced. This one cannot. So find each quotient, and then of course we always write in simplest form. When you are dividing fractions, the first thing you should do is rewrite the problem. 1 over 9 times 12 over 5. And I will want to see that on your paper, 1 over 9 times 12 over 5. And now it's just the rules from multiplication for our previous lesson, multiply across the top and multiply across the bottom. 1 times 12 is 12. 9 times 5 is 45. These numbers are both divisible by 3, so that's 4 over 15. Remember, if you're a cross canceler, if you're going to cross cancel, you would have had 1 over 9 times 12 over 5, and you would have done the reducing right here. 3 goes into 9 3 times, 3 goes into 12 4 times. Now when you multiply across the top, you get 4, and when you multiply across the bottom, you get 15. So it's still going to give you the same answer. It's just reducing within the problem instead of at the end. 3/7 divided by 8. So again, when we divide fractions, we want to multiply by the reciprocal. So the first thing we need to do is write 8 like a fraction. So we write 8 over 1 so that we can take its reciprocal, and we rewrite the problem. 3/7, now it's multiplying times 1 over 8. So we're flipping this fraction, this 8 over 1. Multiply across the top is 3. Multiply across the bottom is 56. 3 actually does not divide into 56, so this is our answer. If you'd like to pause the video and try this one on your own, making sure that you're writing your fraction in simplest form. We have 1/3 times 15 over 7. We're taking the reciprocal of 7/15. If you cross cancel, 3 goes into 3 once, 3 goes into 15 5 times, and you end up with 5/7. If you're not a cross canceler, you would have had 15 over 21, and you would have needed to reduce by dividing by 3. Still dividing fractions, but now we are incorporating negative fractions as well, and our rules still apply for multiplication of signed numbers. We have a positive divided by a negative, so you just need to remember at the end your answer should be negative. So this becomes 5/8 times -4/3. And you can still cross cancel. 4 and 8 are both divisible by 4. 4 goes into 8 twice, 4 goes into 4 once. Now we have 5 times -1, 2 times 3, and you get 5/6. Another example, now we have negative divided by a positive, so we know that our answer still needs to be negative. This is -6/7 times 1 over 12. Again, 6 goes into 6 and 12. It goes into 6 once. It goes into 12 twice. So again, negative times positive, our answer is going to be -1. 7 times 2 is 14. -1/14. And if you're not a cross canceler, for example, this would have given you -6 over 84, and you would have needed to reduce this fraction until you got to 1/14. Mixed numbers. When you're dividing or multiplying fractions that are mixed numbers, we're always going to candy cane them or take them out of mixed number form and put them into improper fraction form. So this is 4 times 3 is 12 plus 2, so that's -14 over 3 times 3 times 9 is 27, 28, 28. Actually, let's do this. It's still division. I'm not going to flip it yet because I want you to see what the improper fraction is first. 28 over 9. Now we want to flip it. -14 over 3 times 9 over 28. There's a lot of cross canceling that can happen here. 3 goes into 3 once, 3 goes into 9 3 times. And 28 and 14 are both divisible by 14. 14 goes into 14 once, 14 goes into 28 twice. This is going to be a much simpler problem. Negative times positive, my answer will be negative. 1 times 3 is 3. On the bottom, 1 times 2 is 2, and we get negative 3/2. You can switch it back to a mixed number if you'd like and say negative 1.5, or you can leave it improper. Now we have an example with some variables, and variables work very similarly to how factors work. So you can reduce fractions that have variables in them, just like you would reduce numbers. So first let's rewrite the problem. This is 5 over 3ab times ABC over 15, because I've taken the reciprocal. So now we're going to multiply across the top. That's 5ABC over, remember that when you have multiplication, you do the 3 times 15 and get 45, and then you just tack the variables onto the back. So the first we need to look at 5 and 45, and those are both divisible by 5. So 5 over 5 is 1. 45 divided by 5 is 9, so we get 1/9. And now, whenever you have a variable in the numerator, it can cancel with the variable in the denominator. So the a's are going to cancel out and the b's are going to cancel out, and you're going to be left with a c in the numerator. And I know that one's kind of tricky, so maybe if you need to rewatch this example and listen to my explanation again, but still multiplied by the reciprocal, still reduced the numbers, 5 and 45, and then we cancel variables that are in common on the top and the bottom. So your answer ends up 1c over 9. In class, we'll work on worksheet 2-4.